Over here we have the program. So over here we define the class LED strip. We have over here some constant variables to define the comfort temperature, the cold temperature, and the heat temperature. Also over here we have instance variables for the pins. Over here you have the constructor. So here we take the values of the RGBW values and then how long you want to keep it on, and we set them up right here. Also we have a void set alarm here. What this does is just sets the previous value to millis, and it sets it into 0, which is a count of the number of times it's run through changing the values. Over here you have the update value. So, so if the in value is less than 4, and while you're still in the time limit, then what you're going to do is you're going to print all the values, and you're also going to write the values to the RGB. Or you're going to write the RGB values to the LED strip. And then also, if in plus 1 is mod 3 is equal to 0, so if in is equal to 2 basically, you're going to set the white pin to 0. Otherwise, you're going to set it to 255. And then you're going to reset the timer, and you're going to increment int. And then if int is not less than 4, then what you're going to do is you're going to, if it's in the time limit, then you're going to set all the values at the highest value possible, and then you're going to reset the timer. Over here we have the start byte value, which just sets this value to the current milliseconds. And here you can see that this value right here just increments as time goes on, so the white value gets larger and larger. And most of the time it'll return false, but once the value gets above 254, that's going to return true, which we can use to trigger the other functions. Over here we have the function that returns up all, which sets all values to 0. Over here we have the 3 functions to find the RGB values, and which just use the temperature and use an algorithm to find out what temperature, what value to set the colors. Over here we have a simple write function which writes the RGBW values. Okay, so over here you have the buzzer class, and here we have predefined tones. So these are the number of milliseconds to keep the tone on. This is how many seconds to keep the tone off. And this is how loud to make it, like the PWM values. And over here we have 2 other tones which are defined later. So here we have the current index of the array, of this array over here, and the current state, which is equal to either 0 or 1 depending on if the buzzer is on or off, and then the tone number of which is selected. Over here we have the constructor, and it just takes the value of the buzzer pin as its parameter, and it sets it in there. And then once it's declared, it's going to set tone 3 on and off to 50. It's going to set all of the values in tone 3 to 50 and on and off. So it's just going to alternate between on and off basically for 50 milliseconds each. Here we have a write value where you can just directly write a value to the buzzer. And here we have play tone, which accepts a number, which is which tone number you want to play. So then it resets the timer, and it sets the index of the array to 0. And then what it does is for each value, it's going to define the values for tone 8, and it's going to set the noise value randomly, but the on and off values are going to be the same each time. Or you have the update function. So depending on which tone it is, and where in the array you are, it's going to update tone 1, tone 3, or tone 8. So it just takes the next value and does that in there. So if it's on, it's going to set it off and then do whatever value is there, whatever value is declared. And while that value is declared, it's just going to keep it in that state. So it'll stay on for 500 milliseconds, or it'll stay off for 500 milliseconds. And then it'll change the state and repeat until it's over. Over here we have the functions that run the program. So first we have the error halt, and what this does is it just takes in a message and halts the whole program by an infinite while loop, and it just prints to the serial port that the program was halted. Here we have a function that searches to find a key, So basically what it does is it takes in values from the ESP serial buffer, and until the value is found, it keeps searching. What this does is you can put the data after a specific keyword next in the ESP serial buffer so you can access it easily. And it will return true if it was done successfully and false if the keyword was not found. Here we have a function that will skip all the output to the ESP, and it will just basically do what it says. It will just skip all the values, skip whatever the ESP says by searching for a new line. And here we have send command, a boolean send command. What this does is it takes a command to send. It takes the ACK bit, which is what the ESP will send if it acknowledges the command, and it will send a true and it will take a true or false value, whether to halt if it fails or not. So what it does, it will print the value to the command to the ESP. It will also print it to the serial port, and then if there was an ACK response, it will skip all the values the ESP gives. But otherwise, until you can find the ACK, it's not going to do anything. Until the ACK is found, it's not going to do anything. And if you said to halt on failure, if you're going to access this if loop if you couldn't find the ACK bit. So then, if you said halt on failure, it's going to halt the command. Otherwise, it's just going to say false. It's going to return false. In all other cases, it'll return true. Here we have a function to connect Wi-Fi. Basically, it will send a command which is connect Wi-Fi, which is defined up there, up previously in the program. It will return true if the ESP returns OK. Otherwise, it will say that the connection to Wi-Fi failed and it will return false. Here we have a function to reset the module, and basically it will just ask to reset the module, and the ESP will say okay if it gets the reset command, and it'll return true if it works. Otherwise, it'll return false. And again, this is defined up in the program. Here we have a find title program, which is basically just finds a keyword that I want before the data appears. So it just takes the title name here. And while you can't find the title, it's just going to keep looking at the next character. And once it finds the title, it's going to break from this. And then next we have the function get next character, and this just reads what the ESP has and returns it. And then here we have the write character function, and basically all it does is it writes whatever character there is to an array, which is defined up here, titled message, which you can see over here. And the size of message is max message size. Here there's a command called return string from int. What this does is there's a string, it takes a string that's empty, and there's also a char, and it sets the boolean escape to false. And for each value in the message index, which we can see up here, it's going to take the value and it's going to, and if it's blank, it's going to decide whether to add the value string to this string. It's going to decide whether to add that character to this string right here. That's all dependent on the escaped value, which is up here. And then escaped is equal to true or false, depending on if rechar is equal to a backslash. And also, then if you're not escaped and the character read is not blank, then you're still going to add the character to temp1. And then at the end, you're going to return the whole string, which has the values you want. Here, this is just a function to set up the ESP. It's going to take the command and it's going to set up everything by setting the mode for the ESP. It's going to create the connection to the server, connect to Wi-Fi, and all that. And here we have two information commands, depending on which server I want to connect to. And so, since the base URL of the server is the same, this is the same. But then the command that it sends is going to be different depending on what I want to receive. And then next we have to get temperatures. Basically, it's just going to find the temperatures, which is in an order. It's going to show you the current temperature, so that's going to be temperature 1. And it's going to take that and get a string. And it's gonna skip 3 temperatures, which is from 2 a.m. and 5 a.m. or something like that. And then it's gonna go to the 8 a.m. temperature, and then it's gonna take the 8 a.m. temperature value, and it'll move on to the 11 a.m. value. It'll take that, it'll read that, and it'll take the 2 a.m. temperature, and it'll read that as well. And it'll convert all of those integers into these global variables, which are defined up here. And then after it takes the temperatures, it's gonna close the connection. Over here it has to get over here we have the get time function, and what this is going to do is just going to find the local time, and it's going to uh, get the it's just going to get the values, and, from the substrings it's going to set the year, month, day, hour, and minute, and then it'll close the connection. Over here, this is all just a formula to calculate what day of the week it is, and if you want to see the formula, it's right here. And basically all I did is converted this formula over here to code over a series of commands. And over here we have the last command, which is to get delay. And it'll take whatever you want to wake up and the minute you want to wake up. And then it'll have the unsigned long delay time. It'll return that at the very end. So what it's going to do is it's going to find out if the current hour is equal to is right before the other hour. It's just going to calculate how many minutes to delay, and it's going to return that. And this is transferring it to, so over here, it's going to calculate the difference between the minutes, and then it's going to convert that to a number of milliseconds that you need. And here, if the current hour is equal to wake hours, what it's going to do is if the minute is greater than the week minute, the minute you want to wake up, that means the time has already passed, so it's going to calculate the value from the next day, how long you need to wait until the next day. And if you're supposed to wake up in the next 5 minutes, it's going to return the value you need to do. And otherwise, it's going to do the same thing, but it's going to leave a 60-second buffer. It's going to call this function again 60 seconds earlier, so you can make sure that everything is working fine. And just in case, over long periods of time, the timer arena goes slightly off, there's still a 1-minute buffer. So after you call this will get it a minute earlier. So for example, if you want to set the alarm at 6:55, this will wake you up at 6:54. And then later, when there's just a 1 minute less, there's less than a 5 minute until the time you want to wake up, what it will do is it will tell you the exact number of milliseconds you need to wait for. And over here we have similar cases, but if the hour is way before the time you want to wake up, or if the hour is greater. And at the end of each one, it's going to return the delay time. And if for some reason none of these conditions are met, it's just going to return 2 minutes as a precautionary thing. Okay, so over here we have the main program. Over here we have the commands to communicate with ESP. Over here we have the command to connect to the server, which is this one right here. Here we can reset the ESP module, we can set the mode, transfer mode, how many connections we want, and the command to close the connection. Over here we set the timeout time, the maximum message size, just the maximum amount of characters the Arduino will hold, and if we want to enable debugging. Over here we have the we set up the ESP software serial, and we have the strings that we want to look for when we're trying to find the time and the temperature. Here we define the array that will store the message, and we'll set the current index to 0. Over here we define the pins for where the buttons will go, and we set the times that we want to wake up, which are right now just arbitrary values. And here we have more variables, and so what this does is this stores the whole time. This stores the day of the week, a number depending on the day of the week, so we can decide if it's Monday, Tuesday, Wednesday, Thursday, Friday, basically so we can decide whether if we want to wake up late or early. And then we have what the wait time is going to be, and the current day, month, year, hour, and minute. So over here we just set all of these to inputs, and we set the buzzer pin to an output. We begin a serial connection, and we set a random seed, so we can use it for the buzzer. And we use the function set of ESP, and we delay for 1 second, and we update the day so we can get the time and what day it is. And then over here what we do is we figure out if we want to enable the alarm and enable the buzzer. So it's just depending on the values of what the buttons are set to. And then over here we get the time so that we can determine what hour and minute is, and we once again update the day. And here we print it to 0 just so we can debug it, just in case there's problems. And in this if loop, or in this condition, you're going to decide whether to wake up late or early. And that's how long you're going to have to wait until you can set up the alarm. And then you're going to print that out here. And then so while that time has not come, so while you're still waiting, you can set if the first button goes high, you can write the red light a bit high, and otherwise write it low. And then keep updating the values if you want to enable the alarm and buzzer. And then over here we have a small delay. And once the time is up, what you're going to do is you're going to set all the values to 0, and you're going to update the day again. And then if the alarm is enabled, then you're going to get the time, and then once again you're going to make sure everything is working. So you're going to make sure that the day of the week is the same and all of that. And then you're going to calculate the delay time over here and over here. Over here we're going to print it to debug, and if the wait time is 0, which means the time to activate the alarm is now, you're going to start the white, and you're going to get the temperatures. And while the white is slowly incrementing, you're going to do nothing, and just the white value is going to get higher and higher. And then once the white value gets the highest value possible, the alarm is going to be set, and it's just going to oscillate between the temperatures of the day. And then while all these 4 or 5 bits don't equal the current day, then you're going to just keep playing a tone on the buzzer, and you're going to keep updating the LED. And then once that's equal, what you're going to do is you're going to make the buzzer quiet, and after 2 minutes you're going to turn off the LED, and then you're going to restart.